All right, so basically these are the steps that you need to follow. Now, once you follow these steps, you are going to get some results, right? You need to always get baseline results, meaning a set of results that is going to be a baseline. You will always come back to that and refer to that. Any design changes should be done only after you have already simulated the baseline design. Change it and then compare it. And if a particular result is giving good results, then take that new result or take that new setup, new design, and test it out in different conditions. The other thing that students do is they always keep the yaw angle 0, right? And today we talked about it. You need to test your designs at different yaw angles to make sure that, hey, you're the baseline design and your new design is consecutively outperforming the baseline design. Only then your new design will become your next baseline design, right? So that is the process of testing, right? Even though you set up your CFD simulation perfectly, if you're just running one simulation and modifying design, that's a huge mistake, because one particular design might do very well in one operating condition, whereas if you go to a different operating condition, it can completely fail. Okay, I hope that makes sense. So I know that I've been talking for a while, but on a scale of 1 to 10, please rate your understanding of the steps that are involved in performing aerodynamic simulations. So how to understand your results? This depends upon, like I said, your objective. So here, for example, we have the Formula 1 car, we have a breakdown for it. Now, this is exactly the type of plots or charts that you need to generate. Now, so for example, here the car has been colored based upon the parts. For example, the front wing assembly, it's right here. So that has been colored with light brown. You can see that the downforce, right, as percentage of a 2009 car. So this is a newer version. So the percentage of a 2009 car, so it's just, there's 30%. Okay, so there is, sorry, my bad. I got confused. So this is actually the downforce. And what is this percentage? Well, this percentage is basically saying that your front wing assembly is responsible for approximately 30% of the downforce. This car is actually a 2009 Formula 1 car. I apologize for the error. And your front wheel, for example, front wheel and suspension, you can see that that is pretty much 0% downforce, right? Because these guys are not responsible for any downforce. Now, let's actually go to our simple simulation that we did. If I go to the simplified simulation that I did, and you can see that this kind of makes sense, because if I look at the front tire or front wheel, you can see that there is high pressure on the front of it and there's low pressure behind it, right? So there is definitely some drag force. Your front wheel is definitely responsible for drag force, but then on the top, you have, say, low pressure, medium pressure, which is green color, and so in the bottom, right? So in fact, in the bottom, there might actually be slightly higher pressure. In fact, this is actually not uncommon. There is a small amount of lift force that is generated at your wheels. This is something that even Formula 1 car analysts observe. And it is very interesting to see that, our simple baseline simulation is able to capture those things. So that's pretty interesting.